Okay, so more probability, more fractions, more favorable outcomes over the total outcomes. But here's where it's going to be a little bit different. We're going to do what's called conditional probability today. So of course there's some formulas, some calculations, etc. So here is what it is. Given events A and B, the probability of event B occurring, so the second one, the second event, B occurring, knowing that event A has already occurred, is called conditional probability. So A's occurred, that is affecting B, that's what we're working on. Now of course you know we always have this lovely crazy notation for it. The probability of B given A. So what's the probability of the second event happening given that the first one has? Now to calculate this, now here's where we're going to take good notes, my friends, good notes. I'm going to try to write small enough so I can fit it in here. So you're going to have your fraction, of course, because we always divide for probabilities. Now, the denominator is the probability of your first event. So notice these match, okay? The top is what we kind of talked about in the past. The probability of the two happening together, A and B. Remember, that's the mathematical symbol for and. Let's scroll this up a little bit. So it looks kind of crazy. It is a little crazy at first, but once we get into it, you'll see it's really not that bad. So, and of course, I'm going to make some notes on the side here because you can see we're talking about in this first example, prime numbers, multiples of 3, odds. We're talking about all the different numbers, okay? So a number 1 through 20 is chosen at random. Find each of the probabilities. So of course, I'm just already thinking about all the numbers 1 through 20. I'm just going to list them so they're in front of our face. 8, 9, 10. 15, 16, 17. You probably write faster than I do. So that's just all 20 of them, so we have them in front of us to look at. Let me scroll this up just a little bit. Okay, so we're calculating the probability that it's a prime, given that it's greater than 8. Okay, so first things first, we're going to figure out what is prime and greater than 8. So I am looking through my blue list of numbers, and I'm looking for prime numbers greater than 8. Give them to me. What's some prime numbers greater than 8? 11.
13, 15, 17.
I heard 15. Is 15 prime? No. Okay, keep going. What else? Well, 19. Anything else? Only over 8, though. We're only going over 8. Okay, so count, easy question, count it. How many are there? 4. So my top fraction up here, my top probability, because you're going to have 2 fractions, is 4 out of 20. So remember I said you're dividing fractions, because look at your formula. The top one, the probability, which is a fraction, the bottom's the probability, another fraction. And like I said, if you need me to show you how to divide these in your calculator, I will. Okay, the bottom, the probability of A. So now I just want the probability of this. So again, there's a total of 20 numbers. I really need to learn to write smaller. So now look at our list of numbers. How many of those numbers are greater than 8? 12, right? 9, I'm not going to I'm just going to do like a big circle. 9 all the way to 20, there's 12 of them. Do you know how to divide fractions on your calculator? Okay, so that's what I wasn't sure of. So I'm going to pull up my calculator here. Let's close this off. Let's get on this. So we're doing 4 over 20 divided by 12 over 20. Probably, honestly, the easiest way, because I'm too lazy to have to pull up all these crazy fraction bars, I'm just going to do parentheses, and I'm going to do the first fraction, which was 4 out of 20, so 4 divided by 20. I'm going to close it up, divided by. Now I'm going to put parentheses around the bottom fraction, which was 12 out of 20. Now when I hit enter, it's going to hit me with a decimal. I'm just going to hit math, enter, enter, and it will convert that back to a fraction answer. Or if you want to give 0.33, you could, because remember, we'll take decimal, percent, or whatever. I know a lot of you like percents. What's 0.33 as a percent? 33. Yeah, so I don't care how you give it, okay? So I'm going to put 1/3, 33%, whatever you want to do. And I'll punch a couple other ones in too. I won't do them all because I don't want to bore you, but I will type a couple other ones in to help you. Okay, let's start with So again, we're doing the combo first, that first probability. So I'm looking at my list of blue numbers. Multiple of 3 and odd. Now let's talk about what multiples mean, because I've been asked this a couple times. So multiple of 3 would be like 3 times 1, 3 times 2, 3 times 3, so on and so forth. So I'm looking through my list. I'm looking at what numbers are multiples of 3 and odd. Let's circle them. What do you got for multiples of 3 and odd? 3. 6 is a multiple of 3, but is that odd? That's out. 9 is a multiple of 3, is that odd? Got it. Okay, 3 times 4 would be 12, but it's even. Out. 3 times 5 is 15, which is odd. 3 times 6, 18, but 18 is not odd, right? It's even. Okay, so just count. How many did I, in orange, circle? 3. So we've got 3 out of 20 for our top fraction. Okay, bottom fraction then, because it's nothing but fractions, my friends. So then we're going to do the probability of an odd number. Well, there's still, of course, a total of 20. So just look at your list over there and count. How many of those blue numbers are odd? Isn't it half of them? Half are odd, half are even. So I'm going to do 10 out of 20. Okay, you try to punch it in. I will punch it in if we need to also. So 30%, 3/10, however you want to give it, I don't care. Okay? And again, I'm happy to punch them in if we're having issues with the calculators. So is it hard? No, but it's a little more involved because we're dividing multiple fractions today. So that's kind of the Debbie Downer part of it. All right, here we go. So at most 15 and perfect squares. Let's do a different color here. At most 15. I'm going to do them in dark green there. And perfect squares. Okay, let's first talk about that phrase, at most. What does that mean? Up to 15. We cannot go past 15. And they also have to be a perfect square. Okay, is 1 a perfect square? Yeah, 1 times 1. What about 2? 3, 4, 2 squared. What would be your next perfect square? 9, 3 squared. What's 4 squared? But I can't go past what? So I'm done circling. Count them. How many did I circle? We got 3 out of 20. Okay, my second fraction. So many fractions. Okay, now the second, the denominator, is all the perfect squares. Well, I already circled some of them, okay? So we said 16. That would be 4 squared. What's 5 squared? 25, which is past our limitations of 20. So how many total perfect squares are there in the list? 4. Because we have the 3 green ones and I added the 16. Okay, punch that guy in. What do we got? Got it, 75% like it. All right, final one of these. I know the yellow doesn't show up the best, but I'm going to try here just for a different color. So 7 and no more than 12. Okay, I think that reads weird. 7 and no more than 12. Wasn't 7 already no more than 12? Like, isn't that kind of built into it? So if you have to be a 7 and no more than 12, I mean, that's my only one. So that's kind of a weird wording, shall we say. Okay, let's do pink for the bottom. No more than 12. So what does no more than 12 mean? You can't go over 12. So we're looking at 1 through 12. How many numbers are there 1 through 12? 12 out of our total 20. Okay, divide that out. I like it, 8.3%. Got it. Now, of course, do you have to list all the numbers 1 through 20 and get dramatic like I was and circling them up? No, no. Somebody can just mentally picture it and do it. Sometimes I think it's helpful to write it out and have it in front of your face. Just a little pro tip. Okay, we're going to do some marbles here. Of course, marbles, right? So bag contains 8 red, 2 blue, 4 yellow, 6 white. chosen at random, find the probability. First thing I would probably do is, what's the total amount of marbles we have?
20.
So add those all together, of course, and we can see we got our total of 20. Okay, now remember, these conditional probabilities, dividing fractions. First, we're gonna do the probability that it's red, this is again weird, and not blue. So really, we're just talking about red. How many red ones are there? 8. 8 out of 20. Okay, now second fraction. What's the probability, or how many of them are not blue? 18, because there's 2 blue, so the rest would not be. All right, punch all that in for me.
44%.
Yep, 44.4, 44%, whatever you want to round to. Like it. Bless you. All right, let's do these yellow guys. So yellow and not white. Doesn't that really just mean they're yellow? So how many yellow ones are there? 4. 4 out of 20. Got it. Okay, my second fraction, not white. So don't count the white ones. How many marbles are there that are not white?
14.
14, because 6 are white, so there's 14 left to be not white.
28.6%.
Love it. Okay. Oh boy, here we are to the vowels again. Now for the vowels, let's just go A, E, I, O, U. So we're kind of all in the same answers here. I know sometimes why, but yeah, okay. Spinner, find each probability. Yeah, okay. Shaded into vowel. Okay, so let's just first total number of letters. Let's count the total here on the spinner.
16.
Let's start with that. So again, just count all of the pieces. Obviously, Sophia did it for 16. So how many of those are shaded and vowels? 3. Shaded in a vowel. Shaded in a vowel. Shaded in a vowel. So 3 out of 16 for the top. Okay. Now, how many are just probability of a vowel? How many vowels are on there? 4, because we got I on here. And of course, divide it out. You know the drill. What do you got? 75%. I like it. All right. I feel like we're doing a lot of vowels and consonants. Consonant and unshaded. So how many of the unshaded are consonants? So count it. We've got 6 out of the 16. I like it. Now, final. How many of them are unshaded? So 7 out of 16. The total 16, of course. You can count those, blah, blah, blah. What do we got?
85%.
Perfect. 0.7%. Or if you round to 86, you know I don't care on the rounding. It doesn't say, so you do you. All right, cards. You know we love our cards around here. Card is chosen at random from a standard deck. Okay, you know it. Just humor me. How many cards in a deck? 52. All right. Find the probability the card is an ace given that it's a diamond. So first question for you. How many cards are aces and diamonds? 1. Isn't there only one ace that's a diamond? So we're going to have 1 out of 52. Okay, and then to get our denominator, of course, it's just our second one we're talking about, the probability of that. Diamonds. How many diamonds are in a deck? 13 out of the total 52. Divide that out. Love it. So again, I mean, it is a little wordier. It's multiple fractions. I don't think it's anything too crazy. At least I hope not. Any questions on the front? Okay, next one. First question. And no judgment here, no judgment. Do you know how many days are in September? Because we need it for this one, the month of September. 30. Okay, so I'm just going to put 30 days in September. Just making sure we got it. Okay, we need that. So the day of the month, September, is going to run at random. Probability that's an even number given that it's before the 20th. So the first thing I need to know, how many evens before the 20th are there? So you can list them. 2, 4, 6, 8, 10, 12, I'm still going, 14, 16, 18. Now, wording, it says before the 20th. Can I count the 20th? No, okay, count them up. How many are there? 9, so 9 out of 30. I should have written smaller. Over. I'm going to cram the other fraction in there. Now, next probability, just that you are before the 20th. Well, how many days are before the 20th? 19. And again, I wish I would have written smaller. Sorry. Sorry. Okay. I like it. I'm just going to round to 47 to make it easy. Okay. Now, 11 and 12 are super easy, I promise. It's just very wordy. Story of our lives. So probability of Jasmine studying for a test and getting an A is 13 out of 16. I like that. That's pretty good odds. 13 out of 16. Studying and getting an A, right? I like it. Okay. Probability she studies for the test, 9 out of 10. I mean, that's pretty high, 90%. I like that too. Find the probability she will get an A on a test given that she studied. Okay, so they have all the fractions in there. We just have to decide how we are dividing them. Meaning, is it going to be 9/10 over 13/16 or the other way? So we're going to read close here. Find the probability she get an A on the test given that she studied. So remember, the top fraction is the combo. She studied and she got an A. So I just reread it. Blah, 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 she studied, got an A, okay, blah, blah. That's our 13 out of 16. And then, of course, the probability that she just studies, that's the 9 out of 10. So, of course, again, because you got to catch study and getting an A. So that's why that was the top one. All right, punch that in. What do you got? 90.3%. Over here, I got more room. Because remember, it's the and, the combo, as I like to call it, the combo probability on top. Okay, so just read it. We just got to figure out how we're dividing this one. Carla has both used and new cars. If 86% of the cars on the lot are new and 45% are new and have a sunroof, find the probability, blah, 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 chosen has a sunroof, given it's a new car. So I need the combo percent first. What percent are new and have sunroofs? 45%. Now, you all have graphing calculators, most of you. You don't have a percent key on there, so you're going to have to put that as a decimal. What's 45% as a decimal? So I'm going to do 0.45 on the top. So we don't have a fraction, which is okay, because we know we can give these as decimals and percents. Now, the bottom, of course, is just the percent of people that have new cars, which is that 86%. Which, again, I'm going to go decimal. No, you punch it in. Yeah. So 52, I heard 52.3, I heard 52, whatever you want to give it. So you just have to read close. Remember, it's that combo probability, the and one on the top. All right, more of the same, We're just going to do it with Venn diagrams and get the numbers off of that. Okay, very exciting, I know. Group of people were asked to drink coffee or tea, the results from the diagram, blah, 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 find each probability. Well, first things first here, let's take a look here. So probability of you drink coffee and drink tea. So just take a look at the diagram. How many drink coffee and tea? 12, the number in the middle. Got it. Okay, your denominator. What's the amount of people that drink tea? More than that. 16. 4 along with how many? 12 in the middle. So our whole T circle is the 12 and 4. Okay, punch that in. What do you got? That will give you a percent.
75.
Got it. I know, the Venn diagrams are fun. Let's do does not drink tea. So you're not in the tea circle and you drink coffee. So how many of them do not drink tea but you drink coffee? I heard 24, I heard 34. 24, because we're just doing the coffee. Okay. Now, how many people drink coffee? Good, on the 36. And the whole coffee circle is the 24 and 12. divide it, what do we got? All right, so 67%, 66.6, however you want to give it. 167. All right, cruising on. Okay, does not drink coffee, oh boy, we got a lot of knots here. Does not drink coffee and does not drink tea. 10. No coffee, no tea drinkers. Okay, the bottom. Does not drink tea. So eliminate the tea circle. How many do you have left? 34, the 24, and the 10. What do you got? Got it. Okay, so the bottom one is more of the same. The thing that's different is they didn't provide you the old Venn diagram. We're going to make it, okay? All right, so let's read it here. Of the 400 freshmen at Westview High School, 92 are in band, 60 are in chorus, 20 are in both. Blah, 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 find the probability. Okay, so we're going to make our own Venn diagram here. I'm just kind of doing my rectangle like above. I've got my band, my chorus. I'm going to draw my 2 circles. Hopefully you draw better than I do. Okay, so I always start with, because I don't know, this is just me, I think it's easiest to start with the middle, the overlap. So read it closely. How many does it say take band and chorus? 20. I'm going to put a little tiny 20 in there, got it. Okay, it also says blah, 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 92 students are in band, 60 are in chorus. Okay, if there's a total of 60 in chorus, how many more do you have for your chorus circle? Total of 60, take chorus. 40. 20, 40, there's our 60. And I'm going to do, of course, the 92. 92 are in band. Well, you already have 20 for the overlap, so how many are just in the band? 72. Because total of 92. Now, we need this number that goes in the corner. How many aren't in band or chorus? Because remember, there's 400 total freshmen. 268. You have to subtract 72, 20, and 40 from 400. Okay, so that's the hard part, is getting the Venn diagram set up. Now it should be hopefully easy peasy. How many are in chorus and band? In chorus and band. 20, the overlap. Okay, your denominator then, of course, is just how many are in band. So when you look at your full band circle, the 72, the 20, 92, divide it. I like it. Okay. Final 2. Okay, not in band and in chorus. So how many are not in band? So eliminate the band circle, but you are taking chorus. 40. So if you take off the whole band circle, there's 40 left for chorus. Okay, the denominator, how many total kids take chorus? 60, the 20 and the 40. 66.6%, 67, whatever you want to round to. All right, final one of the day. Okay, how many kids are in band, in the band circle, not in chorus? 72 are in the band circle, not in the chorus circle. Okay, denominator, of course, not in chorus. How many kids are not in chorus? 340, good on the math. Heskey, how'd you get 340? You're right.
268 plus 72.
Got it. Final answer? And then just round to 21. Round to what else? Anybody miss proofs? Questions? You know?
Yeah, so like for number 72 is not in band, how come like you can't add the 268 together?
Because you're still in chorus, so you're taking one of them. The 268 are taking none of them. None of them at all.
Oh, okay.
Yeah, yeah. Good question. I know the Venn diagrams can be tricky, okay? Come on, stick to that. All right, let me grab your homework.